This lesson is 405, Inscribed Angles and Arcs, Part 1. Give you a couple of seconds to check out this comic. Okay, let's move on. The objectives in this lesson is that you will identify and define inscribed angles and their intercepted arcs, and you will use the Inscribed Angle Theorem and its corollaries to find measures of inscribed angles and intercepted arcs. An intercepted arc is an inscribed angle, the arc whose endpoints mark where the sides meet the circle. And an inscribed angle is an angle that has its vertex on a circle and its sides as chords of the circled. Identify inscribed angles and their intercepted arcs. So you've already learned that the measure of an arc is equal to the measure of the central angle whose sides intersect the endpoints of the arc. So if the central angle is 45 degrees, then its intercepted arc is going to be 45 degrees. You can see that the angle whose vertex lies on the circle has a smaller measure than the central angle. As with central angles, though, an exact relationship exists between the measure of the arc and the measure of your angle. Any arc of a circle that has its endpoints included in the sides of an angle is called an intercepted arc. There are several ways an angle may be drawn so its sides intersect or intercept the endpoints of an arc. The figure shows examples of angles that intercept arc B on circle C. The vertex of the angle may lay inside the circle, such as at points C and E, on the circle, such as point D, or outside the circle, such as point F. When an angle has a vertex on the circle and its sides are chords of the circle, the angle is called an inscribed angle. In the figure, inscribed angle ADB intercepts arc AB. So here's ADB, it's intercepting arc AB. That's an inscribed angle. So when we look at this picture, which angle is an inscribed angle and which is the corresponding intercepted arc? Well, if you look at the picture and you're looking for the inscribed angle, it's going to be MJL, because you're looking for an angle that has the endpoints on the circle and the vertex is on the circle. And so ML, or LM, however you want to say it, is going to be the intercepted arc. The inscribed angle theorem says that angle inscribed in a circle has a measure that equals 1/2 of its intercepted arc. So that means that this inscribed angle, it says x degrees, it's going to be half the measure of the intercepted arc. So if you look at the intercepted arc, it equals 2x degrees. So what is the measure of an inscribed angle whose intercepted arc has a measure of 100. Well, you've got to think there. I said that the inscribed angle is going to be half the measure of the intercepted arc. So in this, you're going to have that, I don't have letters here to use, so this is going to be lengthy in writing it. Your inscribed angle, well, doggone it. Let me go backwards. I clicked pen. Oh, I didn't click pen all the way. That's why it didn't work. There, it works now. So my inscribed angle is going to equal 1/2 of the intercepted arc. See how much easier it is when we use letters to identify? There's not quite as much writing. So my inscribed angle is x degrees. It's going to equal half of 100 degrees. So that's pretty simple. X is going to equal 50 degrees. So you come down here, this is 50 degrees. It's pretty simple. Okay, now we're going to use the inscribed angle theorem to find the value of x, the measure of the intercepted arc. Well, look here, our inscribed angle is 64, and our intercepted arc, FD, is going to be x degrees. So what you're going to do is you're going to say, let me see, I'm looking at my letters, seeing how they go. FED equals half of arc FD. So angle FED is 64. Okay, do y'all remember what you've got to do with that? You want to get that 2 out of that denominator. So I'm going to multiply both sides by 2. So I'm going to get 64 times 2, which I believe gives me 128, equals arc FD. Because remember, if you got a whole number, you want to make it a fraction. See? Those ones are going to cancel each other out, and the 2's are going to cancel each other out. So I'm just left with arc FD. So 128 is going to be the measure of arc FD, 128 degrees. Find the value of x, the measure of the inscribed angle, and the measure of the intercepted arc. Okay, well, we're still dealing with the same information. So you've got your inscribed angle is going to equal half of the intercepted arc. So my inscribed angle is x plus 5, and my intercepted arc, I've got to put my half there, is 3x minus 40. So I want to get this 2 out of the way, so I'm going to multiply both sides by 2, maybe. I'm running out of room over there. So remember, whenever you multiply by 2 on this side, you've got to multiply everything by 2, not just the x. So I'm going to have 2x plus 10 equals, and remember, these are going to cancel each other out. So I've got 3x plus 40. Now, I like to keep my variables positive, so I'm going to subtract 2x from both sides. So I've got x plus 40. And now I'm going to subtract 40 from both sides. Oh, I messed up. Look, this should be a minus sign up here. I was wondering why all of a sudden my answer was changing, because I've worked this problem before and I knew that wasn't the answer. Let me get rid of that plus sign. And my plus sign right here. See, you got to watch yourself when you're doing these. Okay, so let me come back. Minus. That's a minus. So I'm going to be adding it to both sides of the equation. So I've got 50 equals x. So it said find the measure. Okay, find the value of x. Wants me to find the measure of the inscribed angle and the measure of the intercepted arc. So all I have to do is plug in 50 down here. 50 plus 5 equals 55 degrees. Well, you know what? I can either plug my 50 in here, or I can just say 55 times 2 is going to give me 110. Either way, I'm going to get the same answer. Okay, what is the measure of the arc intercepted by an inscribed angle whose measure is 15? Well, if you notice here, we don't have a picture of a circle. So I always like to draw a picture of a circle. That's kind of an oval, but we'll pretend it's a circle. It says, what is the measure of the arc intercepted by an inscribed angle whose measure is 15? Well, 15 is a little angle. All right, this is 15 degrees down here. Woo! So if I want to find out what the measure of this arc is, remember, the inscribed angle is half of the arc. So if I want to find out the arc, I'm just going to take the inscribed angle. I don't know what that was. I'm going to multiply it by 2, which equals 30. So that's how much the measure is of my intercepted arc. Easy cheesy. What is the measure of arc LN? Same thing. If you look right here, the angle is 78. If I say 78 times 2, that's going to give me the measure of my arc. Well, let's do some mental math here. 7 times 2 is 100. It's going to be 14. 8 times 2 is 16, right? Well, let me see. 2 times 70 is 140 plus 16. I'll get it right in a minute. It's way early in the morning right now when I'm recording this. Don't do the mental math early in the morning. I haven't even had my coffee yet. So there you go. 156 degrees. All right, what is the measure of arc AB? Oh, look here. Here's arc AB. Whoa. It's not a very good arc, but you get the idea, from A to B. So I'm just skipping E altogether. Okay, well remember, arc AB is going to be twice the measure of the intercepted, not the intercepted arc, the inscribed angle. Okay, well look here. There are so many different ways you could do this, but what I'm going to do is add those two guys together. That's going to give me 34. So I can come over here and I can say 34 times 2, 68. So arc AB is going to equal 68 degrees. Now, what I did is I took the measure of arc BDE plus, arc, angle, and the measure of angle EDA, and multiplied those by 2 is going to equal the measure of arc AB. There you go. It says triangle WUV is an isosceles. Find the measure of the following intercepted arcs. Okay, so it's an isosceles triangle, so that means this angle right here is also 28 degrees. This angle right here, angle U or UWV, that I'm going to take 180 because that's the sum of the measures of a triangle, minus 28 minus 28, or you could say 28 times 2, which I think is going to give us 56. And then I'm going to subtract that 56 from 180, and I'm going to get 124. So angle equals 124 degrees. Angle WUV. All right. So first we want to know the arc UV. That would be this arc right here. Well, it's intercepted, or it's being intercepted by this angle right here. So let's say the measure of arc UV equals half. No. Not half, 2. Actually, this should be the half over here. Equals the measure of angle UWV. Okay, so I'm going to put X there so I don't have to write all that again. UWV is 28. Oh, I forgot my half. Y'all got to remind me of these things. Too bad it's a recording. You can't really remind me. So I'm going to multiply both sides by 2 to get rid of that half. There you go. That's the measure of that arc UV. Well, guess what? The measure of arc WU is going to be the same thing, because that angle is also 28 degrees since it's a isosceles triangle. And then arc VW. Okay, now watch what they're doing here. Remember, when you have a minor arc, you're only naming it with 2 letters. When you have a major arc, you name it with 3 letters. So when they say arc VW, they're starting at V and going around to W. All right, so this is going to be kind of tricky. We know this arc right here, this angle right here is 124 degrees. 124 multiplied by 2 is going to give you 248 degrees. Okay, the whole circle is 360 degrees. So if I take 360 minus 248, I'm going to have to get my calculator for that. No mental math going for that one right now. 360 minus 248 is going to give me 112. So arc VW is 112 degrees. So watch here. What I did for that one, I took this angle, the WUV that I figured out down here, I multiplied that by 2, which is what happened right here, to get 248. This major arc right here, that equals 248 degrees. So if I want to find out what the measure of arc VW is, I take 360 degrees minus 248, and that arc is going to be 112 degrees. All right. An inscribed angle is an angle whose vertex lies on a circle and whose sides are chords of the circle. An intercepted arc is an arc whose endpoints lie on the sides of an angle. And the inscribed angle theorem states that the measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. After watching this video, you should go through your lesson and complete the student guide, taking good notes for your test and quizzes. Read the lessons in the reference guide to add to your notes if needed. Do the following problems in the problem set. And if you still do not understand the concepts after doing all of this, please contact me or attend TOGA if you have any questions before completing the 4.06 quiz. And as normal, bring any general questions you have to CC with you on Thursday. Also remember to give me your course and section number with all communication, so that way I can help you faster. That's going to be it for lesson 406 on inscribed angles. Thanks for listening.